So next point is dual axis compensation for reliable horizontal and vertical readings. Now, what is this dual axis compensation for the reliable horizontal and vertical readings? If you have seen, almost everyone has seen the auto levels, right? That is the higher version of dumpy level. So in that there is also a compensator. So what this compensator does is it reduces your work during the temporary adjustments. What would used to happen is whenever we used to do the temporary adjustments in the dumpy levels, right, it would require a lot of time to complete the procedure of dumpy level and bring the bubble into the level or bring the instrument into the level. So for that, some compensators have been added that which will make your work easy, which will some instruments have been upgraded to in that such that it will help you to center your station, to level your leveling stations or the instruments easily. And when you're taking the readings, the the compensator will help to get exact readings. This instrument or this various devices that are being used will help you to take exact readings. So this compensator will, if there are any connections, it will take it on its own, right? So it will compensate you the readings. This is available in the case of total stations, right? In the case of auto levels, it is only for the leveling in a temporary adjustment. Here, while when you are taking the readings also, this compensator works to give you a accurate readings, right? Next is new and intuitive software. New and intuitive software means to calculate various calculations, right? As you take the readings, it gives you directly the RLs. It will calculate the distance for you. It will calculate height for you. So all those things calculate area for you, do the countering for you, right? So for that purpose, a software is required, right? It requires some interface to work on, right? When you're working, there will be a screen, as I have shown you in the previous lecture, that there is a screen on which you're going to work. So that screen to work, they require a software on which you're going to work, right? You have a hardware, you require software, right? So that interface will help you to work. So therefore it is there in this tool station. Unique leveling guidance for the fast and convenient setup. The same thing, the dual axis compensation that we are talking about, right? High resolution LCD display means what? It depends upon the model, which model you're going to take of the total stations. If you require a color one, you'll get a color screen display. If you require a black and white, you'll get a black and white, because black and white is cheaper than the color. So most of the institutions have the black and white, right? Next features: audibly notice for a 90-degree turns and layouts. What does this mean? Audible notice for 90-degree turn. This means you can easily change or turn 90 degrees and also the layouts while carrying out the layouts. That is your traversing, right? Electronic laser distance measurement, EDM, you can say. There is also available EDM where you want only to calculate the distance. In that case, right, in case of surveys of roads and railways, when you want to calculate the distance for a long distance, and when you want to calculate the distance for a longer site, that time and only distance, then you can go for this EDM, right? This EDM hardware and this processor is been inbuilt in the total station also to calculate the distance by electronic laser gadgets, right? With the help of the electronic lasers, we are going to use the uh, calculate the distances, right? So that is what it is electronic laser distance measurement, right? Free setup possible straight from the blueprint. It doesn't require a lot of work to set up the total stations. There are not a lot of complications in setting up of the total stations. It is very easy and it is free to set up. Graphic sketch. What is this graphic sketch? When you are taking an angle and a distance of a closed traverse or open traverse, right? As it knows the ground point, it knows the location of the first ground point which you have given, right? That the RL of that known point is to be given to the total station, so that it can carry the, as we require the RL or a benchmark of a known point, so that we can calculate the RLs of the other points. Same way, this total station will calculate the RLs of other points, but it requires the RL of its point, where it is the station point is there, where it is standing, or where we make it to stand. That point's RL is required, right? Once we give it RL, it will start plotting the traverse in its in that screen. As you take the reading and transfer the station point instrument to the station point other point, it will start taking the drawings. It will start drawing it on its own. It doesn't require anyone, because it knows the distance, it knows the angle from that point, right? So it start taking the do the graphical sketchups. It will give the map of that closed traverse. If it's a pentagon, it will show the pentagon. If it is irregular, it will show irregular, right? Hassle-free EDM measurements with a red laser on any targets or a flat prism. We have shown you what is target, right? In the previous lecture, we have saw what is target also. So, with the help of the lasers, okay, as I said, EDM laser instrument measuring devices, what it does is it sends a laser. Once we press the button to measure the distance, right, on the screen, it will send a laser. As we know, it is an electromagnetic property it has, laser has, right? So its speed of that laser will be equal to the speed of light, right? We know its speed, right? We as it as we bisect or intersect the prism or target, and we leave the laser to that point, uh, it will reflect to the prism and come back into the total station. Once the total station receives it, it will measure the time also. It will measure the time. At what time I have sent the laser, it start counting the measure time. Right? When it comes back, it will get a time also. Right? It gets a time. How much duration it required to go and come back. Right? If you say this is your total station and this is your target, right? And this is your laser. When you press measure, it goes and strikes it to it, and again it comes back the same direction, right? It comes back again to the same direction. What is the time? What time this laser require to go and come back? What time it take? Time t. It will measure. Suppose this will measure the distance from the point where you left sent the laser, hit it back, hit it the target, and came back to the total station. That time is measured. That time is measured. Okay. Once you measure this time, you know the speed, right? What is the formula for a distance? What is the formula? Distance upon, we know the actual formula, that is speed is equal to distance upon time. So what we'll do, we want distance, right? We want distance. So what we'll do is shift this to this side. So what will be the formula? Now d is equal to speed into time, that is t. So what is the speed? 3 into 3.6 into 10 raised to 4 meters per second into what time? What is the time? That time when you, it multiplies in the computer itself, in the processor itself, because it has its microprocessor in it. So this microprocessor will process the this values, right, in a few seconds. It doesn't require time also. In a few seconds it will measure it in the microseconds actually. Okay, so when this happens, right, it calculates, it processes the data. It will get, you will give the distance on your screen with the help of this formula, that is distance is equal to speed into time, because the speed of the electromagnetic wave is been known to us, and this total station is been designed to calculate the time that is required for a laser to hit the target and come back. From the point it is left into total station and it came back, that time is been measured. And also you might say that laser is traveling two times, right? It is going back, coming, going and hitting and coming back, right? So you are taking additional time. We want only one distance, right? What I'm trying to say is, if it is going in this direction, we want this distance, right? Again it is coming back, so you are taking the distance two times, right? You're taking the time two times. So for that also there is a compensating, the whatever we talked about, the compensators, right? So that compensator and the microprocessor with the softwares, right, it will eliminate the extra. It will see what is the distance, and there are some uh, uh, compensators that will compensate the corrections, and those corrections will be applied and will get the exact time for only one distance. What time it took for only one time, it will be measured, and that distance will be used while calculating the distance. Next is, enter the data at the office and simply call it up at the site. Means what? Enter the data at the office and simply call it to the site. That is, you can, if you want, if you have some data, you can just preload the data before you go to the site into the total station, and go there and just verify the readings. It is to verify. If you have your readings and you want to verify it, you can do that also. Upload and transfer the data via board data connection. What is this board data connection? Means what? Whatever the data that is being collected into the store in the memory of the total stations, it has a SD card in it, right, where it stores the data. It stores same way like the Excel tables form. How we put the data in the Excel sheet, right? In the every cell we put the data. Same way, it also collects the data in the same tabular form. This can be transferred from that SD card to the computers, and where you can again process those data for the other various works. Next is data editing and exchange in the total stations. You can edit the data there itself. You can exchange the data if there are any errors happening while taking the data. It will not do any error. The error in this total station is done only by the humans. All the errors are being compensated and corrected, right? The errors that might happen is that by the human. Next is connecting to the third party device, that is computers. Third party means a different any other device you can connect to it. You can connect a pen drive to it. That is third party device. You can put a pen drive to the total station from where you can collect it directly. Not necessary that you every time go to the take the total station to the computers, connect it there, and then transfer it. No, if you want in urgent, you can just plug the pen drive and collect the data from the directly from the total stations, and then you can use it anywhere you want. Next is what are the advantages of total station, right? That is, it provides quick setting of the instrument on the trips using laser permit. What I was talking about. This advancement in the survey technologies or the surveying instruments have helped us to improve our time required that was to require before, right? That has been reduced now. Next is it gives initial measurements of sloping, horizontal, and vertical distance accurately and precisely. When it is measuring the distance, if you are not made any human errors, then the formation of error is plus or minus 0.01 meter. 0.001 meter, that is 1 mm is its error. Some of the instruments are 0.1 mm error will be showing you. That is an accuracy of that instrument. Next is it gives digital measurements of vertical, horizontal angles accurately and precisely. It doesn't give the angles and the measurements in the dial reading gauges. No, there are no dial gauging readings. It will give you in front of your screen, whatever the screen we talk about, the LCD display. In that this LCD display, it will show you the all the readings, right? It consists of electronic field book to record the data and additional information. As we have a measurement book, right? We have studied in the first surveying one about the measurement book, right? Used to measure the data. Same way, it has its own electronic measuring book or the field book where it records the data. That is an advantage. It can be used for speedy completion of any type of project works, because only one instrument is required with a high which has very high accuracy. Obviously, the speed of the project will increase and the accuracy also will increase. It provides accurate setting out of works by coordinates method. Now, what is this coordinate method? We'll see in the coming lectures. That is a method of doing the survey in the total station. And we'll see. It is also in the. We'll see what it is in the coming classes, right? So you just understand that it provides accurate setting out of work by coordinates method. There are a lot of advantages in of this. It provides the provision of uploading and downloading the data to the computers. Whatever data you have, you can upload it into your total sessions before going to this site, which I explained in the feature also. Right? Whatever the data which is there in the computers or the total stations, that also can be downloaded into the computers. And either way, you can transfer. It is used to prepare the maps and drawings using softwares. Whatever the data you have collected now on total stations, with the help of the other third party softwares, you can use the data, right? You can use this data to prepare a map or a drawings with the help of the third party softwares. It consists of an onboard area computation program to compute the area of the field with a greater accuracy. You don't require any tape to calculate the area or a chain. Just you require a total station. It will automatically calculate the area for you. Now, how to calculate those area we'll be studying in the coming lectures. We are going to study in depth about it. How we are going to use the total stations, what is the procedure for it, because the way it works in various models, it becomes different, but the main principle of working is same. Next is display graphic views of plots and the lines for the quick visualization. Whatever you have done, whatever the maps you are surveyed, or whatever the area you have surveyed, it will show that in a graphical manner, in a pictorial manner in the screen. So that will help us to understand whether the work done is correct, or whether we have left some places, because the land might be more or less. Mostly in the project works, it is larger case. We are when we go for the total stations, right? So we'll understand when we'll get an overview of our project work that we have carried out. Next is, it provides enormous plotting and area computations at an any user required scale. See, when you are doing the normal surveying works, you do it on the site, then carry that data to the office, and you're going to study it, and then you have to plot it to the required scale. In this total station, it doesn't require. You have to just name the type of scale that you want, in which scale you want. Just you have to name it. It will automatically will plot you in that scale. No need of do it manually. Next is, it allows the integration of the databases, exporting the maps to the GIS packages. Whatever the data you have collected, whatever the plots or the maps you have prepared, that means you means total station is prepared, right? That data can be integrated or can be put or uploaded into the GIS softwares. So what is this GIS software? Just understand the name abbreviation, that is geographical information system. It is, we're talking about the geographical information systems. In the coming chapters we have modern surveying. In that we are going to study. We have studied it, right? In the previous chapter, that is fifth chapter on the modern surveying, you have studied it, right? Using robotic total stations, single surveyor can perform the surveying works. This is little bit morely advanced, so don't need to go in that. Robotic means it will automatically calculate, do the surveying work. Now we are going to study about the disadvantages of total station. Their uses does not provide hard copies of the field notes. Hence, it may be difficult for a surveyor to look over and check the work while surveying. When you are surveying is when you are on the site, right? At the same point, you will not get the readings in a hard copies. That is a disadvantage, because the surveyor has need to look at the readings or the data in that screen itself, in the small screen itself. It's little bit becomes difficult to him. For an overall check of the survey, it will be necessary to return to the office and prepare the drawings using appropriate softwares. Then only you will get to know about the readings or the data that you have carried out. They should not be provided for the observation of suns unless special filters are used. If not, the EDM part of the instrument will get damaged. When you directly look into the sun rays will damage the parts of your total station. That's for the today's class, right? We understood about the advantages and disadvantages of the total stations. You saw there are a lot of advantages than disadvantages. There are hardly 4 or 3 disadvantages of the total station, right? We saw the various features. We saw about the laser plummet, we saw about the dual axis compensators, then we saw about the uploading and downloading and transferring via computers, right? Preloading also we saw. Before we use we do the surveying work, we can upload the data. So all those things are the various features, right, of the total station.